today we are going to be treating electrovalent combination, or this can also be called ionic combination, ionic bonding. Anyhow it's become. Now we actually have two types in chemical combination. This is under this topic. The topic is under chemical combination. We have the electrovalent and the covalent. So, but in this class, I'm going to be treating the electrovalent combination, or you call it ionic combination. Now, the first thing you need to know in this one, in this type of combination, is that it involves electron transfer. Electron can be transferred from one atom or one element to another. Is that okay? This one involves electron transfer. So now let's say, for example, they ask you to look for the formation of what? Formation of sodium chloride. Formation of sodium chloride. Now, what I'm going to do now, I think I've treated how to draw the electronic configuration of any element I've treated, so you can kindly go back to the video and check. But that's because I'm also going to use that method here. Now, we have two elements here, so we have to separate it now. So let's say before reaction, this was here, sodium. What's the atomic number of sodium? Sodium is 11. You get it? Then reacting with chlorine. What's the atomic number of chlorine? Chlorine is what? 17. Is that okay? Now, let's draw the electronic configuration now of each of them. This one will become, it will take maximum number of 2. So this one will, 8 can go. That's 10 now, remaining 1. So remaining 1 will go here. Are you getting it now? So it's reacting with what? This one is what? Maximum number of 2. This one can also have 8. That's 10, remaining 7. This one can also have what? The remaining 7 will go here. This is 6. The remaining 7 will go here. You see that this one is having one electron. The last shell is what we call the outermost shell. While the first shell, this shell is spelled like this. Please take note. While the first shell is called the innermost shell. That's this circle. The inside one is called the innermost shell, while the outer one is called the outermost shell. Now you see that the outermost shell of this one is having 1 electron, while the outermost shell of this one is having 7 electrons. Now, for an element to be stable, the element must either have a complete 8 electron in the shell or a complete 2 electron, the octet structure or the duplet structure. So now, this one is having 1, it is not stable. This one is having 7, it is not stable. Now, what will they do? This element will react because they are trying to attain stability. Attaining stability means they have to either find a way to become a complete 8 in their outermost shell. If element the outermost shell is not complete 8, is not stable. Is that okay? Okay, now let's look at this now. What will this one do? Because this one have 1 electron in the outermost shell, the only thing it can do is to give out this 1 electron. Because the moment you give out this 1 electron, you'll be left with, this shell will break out. You'll be left with complete 8, making it become stable. Then why this one? This one just needs 1 to become stable. It just needs 1 electron. It will be very difficult to give out this 7, but it is easier to look for 1 electron to add to itself. So then this is what will happen now after reaction now. After reaction, this one will give out, this one will transfer. Remember when I started, I said electrovalent combination involves a transfer of electron from one atom to another. If you look at this one, this one is going to transfer its electron, and this one will quickly accept it. So at the end of this round, at the moment it transfers, this shell will break out. We'll now be left with what? This one and what? Complete what? 8. You see now that this one is stable. It's not stable. Your sodium now will become 10. Now, because it gave out 1 electron, it gave out one electron. The ions it will have, the ion it will have become 1. That's plus 1. Is that okay? If it gave out 2, it will be plus 2. Any electron it gives out, that's the number it will carry as the ion. Then this one now that accepted it will become a complete 8. Sorry, let me just quickly put it here like this. This is 8. Remember, the only one that is different in the shell is the one that gave out. That's that meaning now. 1, 2, 3. I think okay, it's complete now. That's 1, 2, 3, 1, 2, 3. You see, it's not having a complete 8. This is the one that it accepted. This is the electron that was accepted, that was transferred from this one to this one. You see, this one was having 3 shell before, but the moment it gave out that one, this shell will break out and become what? Form what? 2 shell. Now, automatically, chlorine becomes 18. You get it? Because it accepted one. Listen, the one that gave out will become positive, while the one that accepts will become negative. Because it accepted one, it become what? Minus 1. Is that okay? So this is how sodium chloride is actually formed. So this one now what? Sodium chloride. This is the formation of sodium chloride using electrovalent combination. So in our next class, I will be treating the covalent combination. Please stay tuned and please subscribe and follow us on all our social media.